Okay, we're in section 102. As always, there'll be contents, examples to look at, and exercises to get busy with. My name is Ron Bannon. This is my draft version of Webster Wells' Advanced Course in Algebra, which dates back to 1904. This document, which is a PDF, is being made available to the prison mathematics project participants only. I do realize that other people may be watching these videos, and they may be interested in getting a copy of this. My email address is Bannon, that's B as in boy, ANNON.US. And this document will be published, but right now it's not published because it hasn't gone through the, what I call, looked at by other eyes. It's only me looking at the document at this point. All right, I've gotten no feedback at this point from anyone. So this chapter over here is certainly a big area of concern, is compound interest and annuities. And Wells treats it as he should, as most algebra teachers would treat it. Certainly when I get to it, I'm going to be going through it. Now, I have better tools available to me, and I want to be honest with you. Some of the tools that Wells had at his availability was the numerical techniques weren't that good at it, all right? And they made some mistakes. They're not substantial, though. They're like pennies worth. It isn't a big error, all right? Now, nowadays, all these computations are being done by computers. And if you look at a financial calculator, financial calculators have these functions built in. Now, my goal here is not to read this to you. My goal here is to show you what types of examples that he went through and how I would look at that, all right? Now, certainly when I do things, it's different than Wells's, and I'll tell you the number one reason why. I have a digital calculator at my disposal, all right? So, I do some summaries for you. I want to point out summaries. I tell you about this discrete compound interest and continuous compound interest. I do talk about annuities, all right? And, a formula for that. The bottom line is I'm not so concerned about, it's nice if you can read through that, understand where that stuff is coming from, and that by reading Wells' section, but I want to get kind of busy with the type of problems they've got. But that's sort of like a summary there, all right? So what I want to do is I want to read the question to you. It says, what will the amount of $7,326 for 3 years and 9 months at 7% compound interest being compounded quarterly? So I'm going to write this down. And, the formula, probably write the formula down first. That's going to be principal, how much you invested, 1 plus the yearly interest rate. I use an uppercase R for that, over the number of times a year it compounded. And then it's going to be the compounding, number of times per year is compounded, times the number of years. All right, so I got to write this stuff down. And writing it down, I'm just kind of reading it. What's P? P is 7,326. All right. What's R? Well, I got to read it. And I got, just first thing, I got this part down. And the R, it says 7%, right? So 7%. Now 7% means 7 parts per 100, which means 0.07. I would definitely hit the decimal because it's easier to type in. All right. The next thing is the time. How much time you got here? And this is weird because they're giving me as a mixed number. So the T is going to be 3 years, and the T is in years, by the way. So 3 years and 9 months. Well, 9 months is 9/12 of a year. All right, let me write that down for you. So it's going to be 3, and 9/12 when you get 3/4, right? And again, I would hit a decimal on that one. It's an easy decimal, too. It's 3.75. All right? Now, what does it say? It says it's compounded quarterly. That means the N is 4 times per year. All right, so what I'm going to do is write it down. A will equal the P, 7,326, 1 plus the R. What's the R? 0.07. What's the N? The N is 4. And yeah, we can do this on a calculator. And what's the power? It's going to be 4 times 3.75. All right? Now, if I were using a calculator, the way it would look on a calculator is, and again, Wells didn't have it at his disposal. This was a big problem for them. They had to do a computation. It took them forever. So on a calculator, this looks like this: 7,326 star parentheses 1 plus 0.07 divided by 4 caret parentheses, 4, star is the multiplication on a calculator, 3.75. And then you hit the return button. And the return button's going to hit, you can return a number back to you. And the number it should return back to you should look something like this over here. Now, what I mean by that, the accuracy of your computer might be different. I'm writing down a bunch of digits over there, but it's a money problem. So what do I write down? I have to write the money amount. So what is it? It's 9503.49. That's how much, all right? So if you invest $7,326 at a 7% annual interest rate that's compounded 4 times per year for 3 years and 9 months, you would come back with $9,503.49. All right, so let's do number 2. And I'm reading it. I'm going to write things down. It says, what sum of money will amount to? Well, now they're telling me the A, and they're asking me for the P. All right, so 1763.5, and I don't know the P. So P it's unknown to me. I have no idea. All right, I have no idea what it is. It says in 3 years, so I know the T is 3 years. I'm just reading. These are years, and the R is 5%. 5% means 5 out of 100, which means 0.05. And yes, I do like the decimal instead. It says it's compounded semi-annually. All right, so what does that mean? It means twice a year. N is 2. It's being done twice a year. So someone says, what's the formula? It's the same formula. What's the formula? A equals P, 1 plus R over N. You may wonder why I use an uppercase R. My lowercase r may not look like an R to you. That's why I do that. But typeset, I use the lowercase r. And then it's going to be raised to the NT. Well, I'm going to write this down for you. This is 17. I'll tell you what a calculator looks like too. 63.50. I do not know what the P is. This is 1 plus, what's the R? Well, 0.05 divided by 2. And I'm going to raise it to a power. And what's the power? Well, it's going to be NT, right? What's N? N is 2. And what's the T? It's 3, right? Well, that looks pretty easy. So I want to tell you what the arithmetic is going to be. I'm going to solve for P, right? So it's going to be 1763.50. Now, on a calculator, division symbol looks like this. Now, what am I dividing by? I'm dividing by this. Well, let's write this down. I'm dividing by 1 plus 0.05 divided by 2. And this is being raised to a power. Now, by the way, the power is pretty easy, right? What is it? 2 times 3 is 6. If you do this on a calculator, the calculator should return this to you, which is what we're saying P is equal to. All right? Now, granted, it's a money problem, so don't write that down. Write a money answer down. So it would be $1,520.66. All right, let's do this one over here. Yeah, mainly a calculator exercise, and certainly Wells did not have a calculator. When I say he didn't have a digital computer at his disposal, they had calculators. There were actually people that did the calculations. And it was actually a job. They actually called them computers. In how many years will $300 amount to? So I'm going to say the principal is $300. And it amounts to this over here, 398.60. And that's the A. And what I don't know is I don't know T. This is their question. I have no idea what T is. All right. I know it's going to take some time for that to happen, though. And then they said the R is 6%. What does that mean? 6 out of 100. And in decimal form, that's 0.06. And yes, I do prefer the decimal, especially if I'm using a calculator. So, and they said, it's compounded quarterly. What does that mean? N is 4. Let's write this down. So we get 398.60. That's the A. P is 300. I'm using the formula. It's going to be 1 plus the interest rate, which is 0.06, over the number of times it's compounded per year, 4. And then when I get over here, this is going to be 4 times that unknown T. Now, this is where they had big troubles, all right? So what I'm going to do is I'm going to try to work through it. And I know it's tough, but I have to work through it. What do you get? 398.60 over 300 equals, well, let's write this down. 1 plus 0.06 over 4 raised to 4t. Okay, what they did next, and this is something that I'm not going to be doing, they had to go through a bunch of things to get the answer over here. I'm going to say I don't need all those tricks. I'm going to take the log of both sides. And I'm going to do the natural log because it's easier for me to write down. So it's going to be natural log of 398.60 over 300 equals the natural log of the other side. And what's nice about the natural log is the exponent would come down. So I get 4t natural log of 1 plus 0.06 divided by 4. All right? Now someone says, what are you going to do now? Well, I got to solve for t. And I'll write that down for you. It's going to be natural log of 398.60 over 300. And now I got to divide by two things. I have to divide by 4, and I have to divide by the natural log of 1 plus 0.06 over 4. And this would be what t is. Now someone says, how do you do it in a calculator? Well, I'm going to write it down. So on a calculator, it would look like this. Natural log 398.60 divided by 300. And yes, a calculator's no trouble with that. Divide by 4 and divide by the natural log of 1 plus 0.06 over 4. And what are you going to get? You're going to get t. Now, by the way, when you hit the calculator button, it's going to turn out to be a number. That number is going to be an approximate. It's over here. All right? So what I'm going to claim over here is that I don't think you'd speak to someone that way. Like if someone how many years and you said, oh, it's going to be 4.77169939847946946, they'd think you're crazy. So what do I know? I know it's 4 years. I know that much. Whoops, I spelled years wrong. Let me do that. I'm going to correct that. And I'm going to do days now. And someone says, well, how are you going to do that? Well, I'm going to take the decimal part, and I'll write this down for you. 0.77. It's tough, though. I know it's tough to write that down. 1699398479446. And that's going to be this. Maybe I should erase that and write down what that is. That's years, right? And then I got to say, you know, how many, every 1 year has how many days in it? 365. So what would I do? I'd take this number, I'd multiply it by 365, years would cancel off, and I'd get the number of days. And I'm hoping if you do that, you're going to get 282 days. Now, by the way, not exactly. I'm rounding off. So after 4 years, 282 days. All right? So let's look at this one over here. I get to the next page and see if I can write things. I got to keep that on the screen, though. And let me just push this on the side. And I got to push this up here a little bit. At what percent? I don't know. So I'll write this over here. I don't know the R. I have no idea. At what percent per annum will $500 amount to? So I know the principal is $500. And they say it's going to amount to $688.83 in 6 years, 6 years, and 6 months. Well, that's easy. What's that going to be? 6 months would be half a year, right? 5 years. I'm not going to write the year down. I think that's obvious to most people at this point. Let me just get my eraser out. So it's going to be 6.5 is going to be the time. All right? So let me say if interest being compounded semi-annually. So what's n going to be? Well, it's twice a year. Well, I got to write it down. And what I don't know is I don't know the R. All right? So I'll write this over here. So you can get 688.83 0.83 equals, let's see, principal is 500, right? 1 plus r, n is 2. And what's that exponent going to be? 6.5 times 2, right? Well, that's going to be 13, isn't it? We need to solve for r. And someone said, how are you going to do that? There's certainly many ways to do it, but what I'm going to do is I'm going to divide both sides by 500. You notice I'm not doing any arithmetic. I'm just writing down what the arithmetic is. To be fair, I want to do the arithmetic in the very end. And what's going to be 1 plus r over 2 to the 13th power. Now I'm going to take the log of both sides. I'm going to use the natural log of 688.83 over 500. And when you take the natural log of the other side, you get what? You get 13. That comes down, right? And then when you get the natural log of 1 plus r over 2. And it's a lot of work, there's no doubt about it. But if you think you've got trouble, just imagine back then when there's no computer, all right? So I got to keep writing it, and it's the crazy part. I got to keep writing that down. So what do I get? The natural log of 688.83. You know what? I just realized I need a little more room. So natural log 688.83 over 500. We're going to divide by 13. And what does this equal? The natural log of 1 plus r over 2. And I really sympathized before digital computer how difficult these problems must have been for people. It employed a whole class of people to do these problems over here. What I'm going to do now is I'm going to write it down as an exponential problem. All right, an exponential problem. Let me see. Oh, I'm sorry. Oh, I'm reading the wrong question. I started reading 5 and I'm on 4. I'm sorry about that. So I got to do this. I'm sorry. I'm looking at the wrong thing. And I was wondering, where's that coming from? But anyway, what we're going to do now is we're going to write as an exponential problem. So it's really e raised to a power now. And what power? Well, it's going to be tough for me to write down, but I'll write it down. I'm raising both sides to the a. All right, this is going to be 1. This side's easy. Oh, boy. Natural log. You know, I'm jamming it in there, right? 688.83 divided by 500 over 13. I know it looks bad. All right, I get my calculator at some point. Boy, this is going to get tough. So it's going to be e raised to the power. I'll put the power down again. I'll be a little bit neater this time. Natural log 688.83 over 500 divided by 13. And then I'm going to subtract 1, and you get r over 2. That looks terrible. I'm going to multiply both sides by 2. You can get 2 e to a power. What's the power? Natural log 688.83 over 500 divided by 13. That's the power. Minus 2 is equal to r. All right, let me tell you what this looks like on a calculator. It's going to look bad. There's no doubt about it. So it's going to look like a 2 star. E on most calculators looks like this over here. E parentheses. What goes into parentheses? Let's write this down. Natural log of 688.83 divided by 500 divided by 13. Let me make sure I'm copying the 13 right. If it's 13, I remember what oh yes, 13. What am I saying? Sorry about that. Now people screw up. I know that. But that's why we give you an answer key. Screw up, look at the answer key. And then minus 2 is equal to r. So I'm going to say when you get r, r is going to be a decimal number. All right? Now, when I got the decimal number, let me show you what decimal number I got. I got this number over, whoops, sorry about that. I got this number over here. But when you say an interest rate, although that is an interest rate, we like to write it as a percent. So you have to multiply it by 100. So when you multiply that number by 100, right? So 100 times R, whoops, 100 times R is approximately 4.99, yada, yada, yada. Now, granted, there's nothing wrong with saying that, but I'm rounding it off to a nearest integer, and I'm going to say roughly 5%. Roughly 5% interest, all right? Let's do the next one. I know we got a lot of chicken scratch over here, and this is an annuity problem, and it's basically a plug-in. So let me just go through. It says find the present worth of an annuity, $150. So the A is 150. Let's see, find the present worth of an annuity to continue for 20 years, allowing a 4% interest rate. So it's 1.04 because it's 1 plus the interest rate. So that's 1.04, and we got the 20 years, all right? And then we write down the formula. This is the form over here, and then we get this business over here, all right? So someone says, how would you do that computation? I'm going to write it down for you, how it looks on a calculator, and I'll write it down. So it's going to be 150 star. Well, I'm going to do the top number first, and that's going to be 1 minus 1.04 caret. I recommend putting that in a parentheses. Otherwise, you're going to be horribly confused. And then I'm going to divide it by 1.04 minus 1. And then you can hit the return button, and you should get this number over here. Now, someone says, what is that number? It's a money number. So what do? You round it off properly. You notice I put over here 2,038.55, not 54. Why 55? Look at the number after the 4. It's 8. Round up. Okay? Now would be the correct answer. I'm going to say for the most part, at least for modern day students, the exercises are basically going to be, can you use the formula and can you use a calculator? All right, so they give you a bunch of questions over here, very similar to what we've given you in the examples. Can you use a calculator? Can you solve an equation? That kind of business. And there's quite a few questions over here. I'd say you got to look through them. Some are kind of easy, but some are more difficult than others. Some require reasoning. I did put enough work down there. In case you get stuck, you can look at my work if you like. All right. Well, a lot of questions, aren't there? How many questions? 15 questions. Then you get to this related SAGE code. What does that mean? It's a computer algebra system or a CAS. I want to point out that modern day financial calculators have these things built in. What do? You just plug in the numbers and it spits back the answer to you. It actually does all the work for you. All right. Go to this website over here. You can download the software, use the interactive web-based application. Hey, really, I put a lot of stuff over here. That's not my interest. My interest is in getting you guys to do the work. What work? The work that Wells has presented to you. So if you have any troubles with my work or my answers, maybe I made a mistake. Maybe you want to say, hey, you know what? I'm working this problem over here. And what I mean by that, you email me, by the way. Let's say you're working problem number 2 in section 102.3. You'd email me. You say, I'm in section 102.3. I am working problem number 2, and I do not agree with your answer. I don't think that's the correct answer. Well, you know what? If that's not the correct answer, I'd have to look at it. Maybe I made a mistake. Maybe I just was daydreaming and put the wrong numbers in my calculator and got that number. Now, I'm real careful, but that doesn't mean I'm perfect. If I make a mistake, please bring it to my attention. All right? Thank you for paying attention.